Continuing further, let's discuss about the star topologies. The star topology you can see in the diagram, which is highlighted by the cursor. It is the most common network topology that you will find in the networking world. And there is a central hub. You can see this is a central hub, and this central hub is nothing but it is an active device like a switch or like a in olden days there used to be a simple hub, dumb hub. But nowadays, you can find a smart hub or smart switch at the center. And to this smart switch, there are various peripheral nodes you can see at the periphery, and they are connected by using a proper media like the coaxial cable, the twisted pair cable, or even a fiber optic cable if you want more bandwidth. So, in this way, the central hub, this is the central hub, and this central hub is shared between all the nodes. Here you can see even a network printer is being connected to the network. And this particular arrangement is very useful because it ensures that there is a minimal data loss. It prevents data loss, and that is the main feature of the star topology. Now, as I said, there are advantages and disadvantages also, two sides of the coin. So star topologies are common because it's very easily they can be designed, they can be deployed on the field, and even managing the network is concerned. This particular network topology is very useful because you can manage the network in a very simple manner. And the main thing is you can manage the network from a single point, because if you manage this smart hub, because nowadays even you can remotely log in these devices, and you can remotely control these devices. So as far as the management of the network is concerned, this becomes a very useful kind of management scheme. And then every node is independent, so there is no relation that a particular node, suppose it fails, then it will not affect the other network, entire network. We'll see some other topologies wherein if one particular network node fails, then it the entire network will be down. So that is not the case with the star topology. So each node is independent. It is independently connected to the central hub, and then it also functions independently. It doesn't affect its uptime or the downtime doesn't affect the entire network. And one more thing is very easily the entire network can be managed. As far as the scalability of the network is concerned, suppose if you want to add a device to the network, you can simply put a device to the network and make a connection with the central hub. So adding a device, removing the device is very easy. You don't have to entirely redo the network designing as far as the uh, scalability is concerned, or even the down scalability if you want to remove the devices. Uh, and even there is other advantage, like it requires little cabling to fully connect the network, unlike the other topologies where a lot of cabling is required. So if you put more cables, that means there are more chances of faults in the cable, and then the entire downtime of the network will be more, right? And there are chances that uh, there could be some faults in the cables, and then troubleshooting also becomes very difficult. So that is the main thing about the star. Little cabling is required, and therefore it is very easy to set up the network, to manage the network, to troubleshoot the network, and it's very simple for the network administrator, because the network administrator can very easily troubleshoot the network, very easily lay down the new devices, add the new devices, remove the new devices, manage the devices. So all these things are there, are the advantages of the star topology. Now, there are some downsides, like disadvantages of the star topology. You can say flip sides. The main important thing, if the central hub goes down, then the entire network will be down. The entire network can't function. So therefore, central hub is very, very important, and the network administrator has to manage the central hub. The central hub should be monitored all the time, so that whenever there are chances of some faults in the central hub, then you must have a redundant hub, a redundant device, so that it can be replaced in no time. So this kind of additional issues are to be taken care, and this is the main downside of the star topology. The entire thing is that the central node is very important. So the choice of the central node decides the overall bandwidth and performance of the network. So in star topology, the main thing is the central hub, the central switch. Okay, if you deploy a very good central switch with stringent kind of specifications, then you can make sure that this particular network will be a well performing network. Right. So that is about star topology. I hope you have already, you can as well go through the text, and you can get more idea regarding the star topology. Just look around and try to locate where star topology is being deployed in the computer networking world. Now the second topology is the bus topology. In bus topology, you can see that it is like a bus. You have been studying the microprocessors from graduation, BSc first year. So you know what is a bus. So a bus topology is like orienting all the devices on the network along a single cable, running in a single direction from one end to the other end of the network. And therefore, sometimes this is also called as line topology or backbone topology. But because there exists a backbone, and to this backbone, the devices are getting connected. So therefore, bus topology, it resembles like a bus, and there is a backbone, there is a cable. It could be even a fiber optics cable, but it is running from a single direction from one end of the network to the other end of the network, and data flow occurs on the network, follows the route of the cable moving in one direction. So this is the main thing about the bus topology. We'll see the diagram of the bus topology. So this is the central path, or this is the backbone, or this is the line on which the data is flowing, and then there are nodes which are arranged on the either direction of the bus. So this is looks like a bus, therefore it is called as bus topology. We'll see the advantages. The advantages are, it's a very cost effective choice, because uh, the entire design is like if the main cable is important. Unlike the star topology, there is no central hub. So if the central hub fails, then the entire network goes down. That was the issue with the star topology. But in the bus topology, that issue doesn't exist, and all the devices can be connected via a single coaxial or RJ45 cable. You will see that typically in a bus topology, they use single coaxial cable or RJ45 cable. We will come to this very soon, that what kind of cables and what kind of connectors. So more nodes can be added to the network by just by joining the additional cables. Okay, of course, it will be more of cabling, but that can be done very easily. Now the downsides or the disadvantages of the bus topology. They use a single cable to transmit the data. So whenever a single cable is used, that is the lifeline of the network, and therefore it's vulnerable. Like suppose the cable is like damaged by rats or by some other means, then the entire network will stop. So the failure of the cable will affect the entire network. And you know that whenever cable has to be replaced, then the entire cable has to be removed, and then it becomes a lot of time consuming and expensive to restore the network, because the entire cable has to be replaced. So therefore, when it comes to the downside of the network bus topology, the maintenance issues are more in case of bus topology. And bus topologies, they are very well suited for small networks, because there is only not much bandwidth required for these networks. And you know that if you add additional node, then the additional node will consume the bandwidth, and then there will be entire slowing down of the network. The data typically on the bus topology is half duplex. That means it can't be sent in two opposite directions at the same time, like the full duplex kind of transmission. So this is not the good choice, ideal choice for the network wherein the high bandwidth is required. Like if you want to lay down a network for video applications, then this is not the ideal choice because the bandwidth is often limited and it's not practically possible that both the direction traffic exist at the same time. So therefore, these kind of networks are typically used where there is not much traffic on the network. So this is all about the bus topology. We'll see ring topology in a while.